Right. Welcome back to the beginning of Chapter 6. I've been postponing Chapter 6 because we needed to make sure we finished up everything on Chapter 5 first, and with all the disruptions here, this is the way the schedule worked out. Well, this section is entitled Quadratic Functions, and it's a pretty important section, so I didn't want to miss it this year, make sure we had a chance to cover it. The word quadratic has quad in it, but really this isn't so much about 4 as it is about 2. Quadratic functions are equations or functions where the exponent, the leading exponent, is a 2. Y equals x squared, or we could say f of x equals x squared. When we had x to the first power, those were linear equations, and quadratic functions are x squared. So this equation right here is the basic, the simplest quadratic function you can come up with. And then what we're going to do is we're going to continue to modify this equation little by little, just to make it kind of move around on the graph. So your first assignment tonight is going to be to graph quadratics, and this function is going to have other things involved with it. For example, it's going to look like this: some number, we'll call it a, x squared, plus some number, we'll call it b, times x, plus another number, we'll call it c. A, b, and c are just integers. A, B, and C are just, actually they don't have to be integers, they can be fractions as well. They're just real numbers, okay? They're just real numbers. Any real number that you can put in there would be A, B, and C. But one thing we need to notice, that A cannot be 0, because if A was 0, then 0 times x squared would be nothing here, and this would not be a quadratic. It'd be a linear equation instead. So A, B, and C are just real numbers, but A can't be 0. Now, the quadratic function is pretty basic shape. Let's take a look at it. All right, here's again the most basic quadratic function. And I want to go ahead and graph this manually, just so you can see what has to be done. We're going to go ahead and graph this. And to do that, I'm going to make a table. And I'm going to pick some values. I'm just going to pick them out of the air. Let's pick a couple negative values and 0, and a couple positive values. Picking values like I just did here, you're really taking a chance, because you really don't necessarily have a very good range of values to pick. But we're going to pick these just for the moment, okay? Well, let's start with 0. If x is 0, 0 squared is 0. That's right. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. Let's go back the other way. If x is a negative 1 squared, negative 1 times negative 1 is a positive 1. If x is negative 2 times negative 2 is a positive 4. And what you'll notice here is that there is a symmetry to these graphs. In this particular graph, I picked 0. I knew that 0 was going to be the center of my graph, and there's going to be a symmetry in these numbers if the values you picked for x are symmetrical as well. So let's go ahead and graph this. If x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 4. If x is negative 1, that's 1. If x is 2, it's negative. X is negative 2, it's 4 also. Now, we only picked integers here, but we could have picked all the decimals and fractions within these. So I'm going to go ahead and just draw a graph with just a continuous curve that stretches out here in this particular shape. Now, this shape is called a parabola. And a parabola is the product of a quadratic equation, a quadratic function. And parabolas represent lots of things that we do in nature. One of them is gravity, and we'll get into that in a little bit. This is the most basic quadratic you're going to find, is where a is 1. There's 1 right there. And it's sitting right on 0, 0. Well, this place right here at the bottom where the graph turns around is called the vertex. Just like the vertex on polygons, it's a place where these two curves meet. That's called the vertex. And what's going to be critical that as we go to graph these, that we know what that vertex is, because if we do, we can graph some symmetry around that vertex. If we don't know the vertex, we're just kind of guessing at our numbers. Let me give you an example here. All right, here's a quadratic. We're going to go ahead and graph this thing. And I'm going to make a table again. And I'm going to pick those same values that I did before. Not that I have no idea, if these are going to be very good or not, but we're going to check it out. If x is 0, well, 0 squared is 0. 0 minus 4 times 0 is 0. That's still at 0. And x is 1. 1 squared is 1. 1 minus 4 times negative. 1 minus 4 is a negative. 1 minus 4 is a negative 3. And 2 squared is 4. 4 minus negative 8 would be a negative 4. And I'm suspecting that this is symmetrical here, so let's put in negative 1. Negative 1 squared is 1. Negative 4 times a negative 1 is 4. Positive 1 plus 4 is 5. Oh, it's not symmetrical. Let's put negative 2 in there. Negative 2 squared is 4. Negative 2 times negative 4 is 8. 4 plus 8 is 12. What do we got here? Well, 0 went to 0, and 1 went to negative 3, and 2 went to negative 4. Negative 1 went to 5. Well, and negative 2 went way up here to negative 12. I'll just make a mark there. Now, you'll notice that this doesn't look like a parabola. And the reason is that number in the middle here is not, in fact, the center of my graph. So it's going to be very important that we know how to figure out where the center of the graph is. This is not showing me a parabola. I have no idea. I have an idea it's probably over here somewhere, but I don't know exactly where the center is. So one of the most important things we have to be able to do is find the center of that graph. And we're going to do that with a brand new formula. Here it is. All right, let's take a look at this just in the general case. The vertex, this spot in the middle here, is in this particular case, it's at the bottom, and then the graph turns around and goes back up. This vertex here happens to be the smallest point of my curve. We could call it the minimum. It happens to be a minimum. If this graph were upside down and shaped this way, then this thing up here would be called a maximum because it's upside down. But this vertex right here, we need to be able to find that. Now the vertex is also sitting right on what we call the axis of symmetry. I'm going to abbreviate that with the letters AOS, axis of symmetry. Axis is just a line. Symmetry, of course, is what you know it is. It's symmetrical about that particular line. The same shape on both sides of the line. Well, the formula for finding the vertex or the axis of symmetry is found by this formula. The x value is equal to negative b over 2a. Negative b over 2a. So let's take the equation we just had a few seconds ago here. X squared minus 4x, I think it was. And let's go ahead and figure out what the axis of symmetry is, or what's the x-coordinate of that vertex. Now remember that this is ax squared plus bx plus c. So this is a right here, 1, that's a. And this number right here is b, and we don't see the c value out here. It's out here, but it's 0. So this is c. So we're going to use this formula to find the middle of this graph that we just graphed a few seconds ago. So x is equal to negative b, well, a negative 4 over 2 times a. 2a, well, a is 1, so 2 times a, or I end up with positive 4 over 2, which is 2. So it tells me that the center of my graph, the vertex, is going to be at 2 something, okay? And then if I want to, I already figured it out earlier that if I stuck 2 into this equation, I ended up with negative 3, I think it was, okay? But the vertex is, the x value of the vertex is found by using this formula. This is a critical formula. This is one you'll have to memorize and know it really well. Also then, the axis of symmetry is found on that vertical line at 2. So let's graph that, okay? We know that the axis of symmetry is at 2. 1, 2. And if that's the axis of symmetry, we know that the vertex lies right on that line. So it's at 2 something. This is the axis of symmetry, AOS, and its equation is x equals 2. X equals 2. Now we just have to plug that value in here, that 2 back in here, to see exactly what did we get. Let's see, 2 squared is 4. Minus 4 times 2 is minus 8. 4 minus 8, let's see, 4 minus 8 is a negative 4. 4 minus 8, yeah, and negative 4. So the vertex is found on the axis of symmetry, 2, and the y value then is a negative 4, right there. So why is this important? Because when I go to make a table now of values, I know that the middle number on my graph is the vertex. I'm going to put a 2 there with a big V. And I know that my vertex is found at 2, negative 4. Well, if the vertex is found here, then I can pick values on both sides of this that would be better values to pick. You don't really want to pick these values until you know where your vertex is, so that you can kind of work the problem on both sides of this. So we know that if x is 0, y was 0, and if x is 1, y was a negative 3. I know that this is probably symmetrical now. So put 3 in there. 3 squared is 9. 9 minus 3 times negative 4 is a negative 12. 9 minus 12 is a negative 4, a negative 3 again. Put 4 in there. 4 squared minus 4 times 4, 16 minus 16 is 0. So yeah, you see again that we've got symmetry now. So what's important here is to notice is that you've got to find that vertex and the axis of symmetry first. Let's do another one of those. All right, you're going to be asked to graph this, okay, be able to know some things about it as well. So I want to find out where the vertex is. I'm going to make a table in a second, and I want that vertex to be right in the center of my table. Then I'll pick values on both sides of it. Well, let's use my formula. Again, this is A, this is B, and of course B has a sign on it, negative here, and this is C. C is unimportant to us on this particular exercise. So here we go. Negative B, well, that's a negative 2. The x value is equal to a negative B, well, that's to be a negative 2 over 2 times, I'm sorry, I got that backwards here. X is equal to negative B, which is a negative 8. Messed up there. B is a negative 8, so negative 8 over 2 times a, which in this case is 2. Let's do that again. Negative b, so negative 8 over 2 times a, which is 2. So what do I get here? I got 8 over 4, or 2. So it tells me that my axis of symmetry and my vertex is at 2 something. Okay? So now I know that my vertex is going to be at 2 something. I can go ahead and pick some other values on both sides of this. So I'm going to go down by 1 and down by 1 and up by 1 and up by 1. By the way, if you get a fraction here, picking those values that are fractions is not probably wise. We will do one here in a minute where we'll get a fraction for the vertex, and it will not make sense to pick values that are just going up and down by 1. Well, let's put these numbers in, okay? Here we go. I'm going to erase this so I can work underneath here, okay? Let's start with 0. If x is 0, 0 squared is 0, times 2 is 0, minus 0, plus 9. So that's 9. Let's put a 1 in there. 1 squared, x squared, 1 squared is 1, 1 times 2 is 2, minus 8 times 1 is minus 8, plus 9, that's 11, minus 8 is 3. Let's put 2 in there. 2 squared is 4. 4 times 2 is 8. 8 times 2 is a negative 16. Plus 9, that's 17 minus 16 is 1. Let's put 3 in there. Now I'm suspecting that 3 is going to give me 3. Let's find out. 3 squared is 9. 9 times 2 is 18. Negative 8 times 3 is a negative 24, plus 9. Let's see, that's 27, minus 24 is 3. Yeah, I got 3, that's right. Okay. And then let's put 4 in there. 4 squared is 16 times 2 is 32. 4 times negative 8 is a negative 32, plus 9, that's 0 plus 9 is 9. So there you go. We end up with a parabola where the vertex is at 2, negative 1. 2, negative 1. That's my vertex. I've got some ordered pairs at 1, 1, 3, and 0, 9. Okay, that's way up here. And another one at 3, 3, right here. And at 4, 9, again, way up here. I'm not going high enough here. But there's my parabola, okay? Now this parabola is a little bit skinnier than the last one we did. But there you go. Parabolas may be skinnier. They may be stretched up vertically. They may be flattened out. They could be real flat. So this is the idea. Be able to tell where the vertex is, and the axis of symmetry is going to have the same value as that x value. This axis of symmetry has to be x equals 2. It's the same. These are going to be the same every time. The axis of symmetry and the vertex, because the vertex is sitting on the axis of symmetry. Now let's try one where we end up with a vertex that's going to be a fraction. Alright, let's tackle this one. We're going to end up with a fraction as a vertex on this. And I want to show you kind of an important characteristic here that you're going to want to avoid. Alright, this is A, and this is B, and C is out here. It must be 0. So here we go. The x-coordinate, and by axis of symmetry, the x-coordinate is negative 10 over 2 times A, which is 3. And I end up with a negative 10 over 6, which reduces to negative 5/3. Negative 5/3. All right, now when we make a table here, I'm going to make it over here this time, my vertex is going to be in the center, negative 5/3. Okay? And it gets a little bit challenging to stick these numbers in and make them work. So we're going to talk about how to use the calculator to your advantage here. Now, what you don't want to do is go go and put a bunch more fractions on here. It gets exceedingly difficult to calculate these as if they're fractions. But if I went just a little bit to the right on the graphing, or on the number line, and put a -1 here and 0, and then went back to the left and put, say, a -2 and -3, these numbers are now not evenly spaced. They're not evenly spaced, so I cannot expect symmetry in my lines in my y coordinates over here. All right, let's calculate some of these. I want to calculate that fraction last because it's just a lot of work. So here we go. If x is 0, y is 0, and yeah, if x is 0, these both go out and end up as 0. If x is -1, well, -1 squared is 1. 1 times 3 is 3, plus a -1 times 10 is a -10. That gives me a -7. Let's go up here to -2. -2 squared is 4. 4 times 3 is 12. 10 times a -2 is a -20. 12 and a -20 is -8. Notice these are not symmetrical. Aha. And the last one, -3 squared is 9. 9 times 3 is 27. And -3 times 10 is a -30. 27 and -30 is a -3. Notice there's no symmetry here. And that's because my x values were not evenly spaced, and I deliberately didn't pick a bunch of fractions. Now I could have, but that's a lot of work. So finally, let's go ahead and calculate this thing. I'm going to erase all of this here. Let's calculate this vertex using this x value. So 3 times -5/3 squared plus 10 times -5/3. Okay? Look at this, all this extra work we're going to have to do. This is 3 times 25/9 positive minus 50/3. Wow. Look at that. Oop, 50/3, not 50/30ths, 50/3. Okay, well, let's see. This reduces and becomes 25/3 minus 50/3 gives me a -25/3, which is -8 1/3. Okay, -8 1/3. That looks about right. Let's see what that would look like on a graph. Okay, let's put the graph right up here. Okay. -5/3. Well, there's -1, -2, -5/3 is like right in here. -8 1/3. 1, 2, 3, 4, 5, 6, 7, 8. You like right in here. -1 goes to -7. -2 goes to -8. I'll put that right about there. -3 goes to -3. 0 goes to 0. There it is. Now it's not symmetrical. The dots are not symmetrical, but the graph is, and the axis of symmetry is that odd number, -5/3. Okay, so now this was a lot of extra work calculating all of these numbers. Well, the good news is your calculator is able to do this for us quite readily, but we still need to know where the vertex is. So let's try this problem using a calculator. All right, we're going to take the same equation and we're going to plug it into my y equals screen. So let's make this just a little bit bigger so you can see it a little better. Same equation. Okay, there it is. Now, if we go ahead and graph this, we're going to hit graph. We'll see a graph, and it should be similar to the one we had before. So let's go ahead and graph it. Yeah, that looks about right. It did go through 0, 0 there, as you can see. It was going through 0, 0. And if I am certain that this is right, then the table ought to be correct. Let's go take a look at table. So I'm going to go second graph here, second table, and I have some values on this table that we saw when we did the problem earlier. Remember, we said 0 went to 0, and -1 went to -7, and -2 went to -8. And as you look at these numbers and study them, you'll notice that the y values are getting smaller and smaller and smaller until you get right here, and then they get bigger and bigger again. But the vertex is not at -2. These numbers are not symmetrical. So we already know that the vertex here, the vertex was at x equals negative, what was it, 8 1/3? Negative 8 1/3. Now I don't see that here on my, I don't see that here, but it's got to be between -2 and -1. I'm sorry, the y value was at negative 8 1/3. The x value was at negative 5/3. Okay, so the x value was at negative 5/3 here. Now you don't see it on the graph on the chart here, but you have some values that you could plot those points, and you could plot several of the points that we had plus some other ones. So whether you use your calculator or not, it may not tell you what your vertex is. So you're still going to have to know how to find this vertex using this formula. You got to know this formula. And if you don't have that formula burned in your brain, you're not going to be able to find the vertex on the more complicated problems. The vertex is not necessarily going to be easy to find with your calculator. Now I want to go back and look at the calculator for a minute. If that vertex is really at negative 5/3 something, let's draw a vertical line right here. And if you remember, we can draw a vertical line by using the draw feature. Let's go do that, okay? I'm going to use the draw feature on the calculator here. I'm going to go second, draw, vertical, okay? And I want a vertical line at negative 5/3. Now don't put a decimal in here, because if you do, you have to round that decimal. We don't want that decimal to mess up our graph. So I'm going to go ahead and graph it. I'm not seeing it. What's missing here? Let's find out. Second, draw, vertical. Oh, I didn't hit enter, that's why. I got to hit enter. There it is. Now, I'm going to make this a little larger so you can see it. But you'll notice that our axis of symmetry is now drawn. So you can't see the axis of symmetry using table. It will not help you. So you're going to have to know how to find the axis of symmetry and the vertex point using this formula. It's extremely important that you know how to use negative b over 2a. Memorize it. It's easy. And then you can draw an axis of symmetry in here, right down the center. Okay? All right. Now, we need to know that some parabolas open up and some of them open down. It's pretty easy to tell which ones will do what because of the value that a is. Let's take a look at this. Here's our basic equation, ax squared plus bx plus c. There's your basic equation. Now, if the a value up in the front is positive, you're going to get a graph that opens up. It's opening up. It's just like it's the normal way in which we see it. So if it's positive, it will open up. And if that a value is negative, it will open down. See how it's opening down here, okay? And you can tell by looking at the equation what the a value is, whether the thing's going to open up or down. So that's kind of a critical piece. If it's positive, a is positive, it opens up. If a is negative, it opens down. So that's a quick way to tell whether your graph's going to open up or down. Well, let's do one on the calculator so you can see that. All right, in my y equals screen, I have put two equations in here. Both of them are quadratics. How can I tell? Well, because there's an x squared term in the problem. y1 has a positive a value, positive 3, but the value that it's positive. So I'm expecting this first graph, when we graph it, to open up. And then y2 has a negative out in front. Okay, by the way, you know that it's going to take the x squared first and then it's going to apply the negative. We're not squaring the negative here. This second one should be opening down. Let's take a look at what happens when we graph. I'm going to hit zoom standard. Let's see what happens here. There's the first one opening up. There's the second one opening down. Okay? Positive A values cause it to open up. Negative A values cause it to open down. So this is a kind of a slick way to tell which way your graph is going to transpose. All right, one last thing. Let's go back and take a look at these two pictures again. As we moving along from left to right here, this graph is going south, it's going south, it's going down. It's going down. At some point right down here at the vertex, it hits what we call a minimum. It's a minimum. It goes down that far and no farther, and then it's going to go back up. Opposite of that is over here on a graph that opens down. As we go from left to right, it's getting bigger and bigger and bigger until it gets to that point right there at the top where this is a maximum. So a maximum, and then it comes back down again. And what that's telling us is that anything that has a positive, if A is positive, it has a minimum. And if A is negative, it has a maximum. You're going to be asked that question. Just look at A and you can tell, oh, A is positive, it's got to have a minimum. It's coming down, it's opening up. And oh, A is negative, oh, that's got to have a maximum because it's opening down. So you're going to be doing several problems there tonight. And then I'm going to go ahead and have you do a couple problems tomorrow. I'll do a couple problems for you, which are word problems. Okay, let's just quickly summarize. This is formula. I've left it up here the whole time. This formula helps you find two things. It helps you find the x-coordinate of the vertex, and it also helps you find the axis of symmetry. Axis of symmetry. They're the same thing. So this is going to be like x equals some number, okay, like -3 or something. And this one will be helping you find the vertex, which is like the ordered pair -3 something, okay? So it helps you find these two things. Second thing is that any graph that opens down has a negative, A is negative, and it has a maximum. And any graph that opens up, the A value is positive, and it has a minimum. So what are we talking about? Well, the basic form is the y equals ax squared plus bx plus c. There's your A value there, okay? There's your A value. Check out that A value. Now this is pretty much all the information you need for this first assignment. We'll do some story problems on the next video, and go ahead and answer these. This is a kind of a critical part of algebra, so make sure you spend a lot of time on this. Let's look at your assignment for tonight. All right, so tonight's assignment is going to be number 36. It's on page 290. I'm asking you to do 1 through 43, every other odd. That's abbreviated EOO. That's like doing 1, don't do 3, do 5, don't do 7, do 9, don't do 11, do 13, and so forth. So just do every other odd. You may use your calculator to help you come up with ordered pairs that you can graph. And I want you to graph these on paper. Doesn't have to be graph paper, but you're going to use your calculator to help you find ordered pairs to graph. But you must use the formula x equals -b over 2a to find that vertex and the axis of symmetry. You must use that. The calculator is okay for other ordered pairs. Okay? So go ahead and practice this tonight, and I will give you some more problems tomorrow with our word problems. Have a good one.